Hello, everybody, and welcome. My name is Lars, and I'm a molecular biologist in Halmstad, Sweden. I'm employed by the Clinical Chemistry Department, where I'm responsible for the human genetics section, but I also work for the Clinical Microbiology Department and the molecular diagnostics section. The presentation I'm going to have here today is going to be about the work we have done to automate the otherwise rather laborious sequencing workflows. And as many of you might be familiar with, the protocols for nanopore kits involve a lot of steps. So the process as a whole requires that you get each and every one of those little steps right. And this can sometimes be asking quite a lot. So especially if we work here in a somewhat stressful environment where other instruments are running in parallel or when meetings need to be attended, etc. So it could be a bit difficult to do everything by hand. So being able to make the sequencing workflow simpler is something that we find very important. Otherwise, it will take much longer time to learn, and it might also become an art to perform rather than standard procedure like anything else. So it is important for us that everybody that does this here should also be able to do it just as good as the next person can. Let's see. So let's begin by taking a quick look at our workflow as a whole. We use two different extraction platforms depending on the origin of the samples. The main platform is the EC2 Connect, where we extract bacterial colonies for whole genome sequencing, and nail and skin tissue for fungi, and eSwabs for SARS. But for the more sensitive samples, such as those that originate from sterile sites, we use a mag lead. And this one is placed in a completely different room where no other microbiology samples are handled, so that we are able to limit the risk for contamination. And the step I'm going to focus on today is what happens after the samples have been extracted and before they are loaded on the MinION flow cell. And in my opinion, this is the most laborious part that requires a lot of focus, steady hands, and plenty of uninterrupted time if it is done by hand. And I don't have very steady hands, so I prefer to have it automated. So the key instrument here is the Myra liquid handling system. I will not have time to talk much about the instrument in general, but instead I will focus on how it can be applied on two different nanopore kits. And these are the ligation-based MAB kit for 16S and ITS, and the rapid barcoding kit for VGS and SARS-CoV-2, and possibly also for other in-house targets if one chooses to validate something else as well. The instrument comes with most of the accessories that you need, except for this magnetic station. And this is the device that is needed for the Ampure beads and for the cleanup procedure. It has a slider that allows the instrument to control which vertical rows that are magnetized at the time. So this is how it is possible to automate the cleanup step. And you might also want to have an extra microcentrifuge loading block and an extra plate loading block. That is, if you want to set up everything the exact same way as we have. So I'm going to talk about three different setups. The first is the 16S setup with the MAB kit, and the whole genome sequencing setup with the rapid barcoding kit, and the SARS-CoV-2 setup also with the rapid barcoding kit. And after that, I will go through the library prep in more detail, and so that you can see exactly how the liquids are pipetted back and forth. And I will also show how the normalization works and how the Myra can do the math for you. And lastly, I will also show you how Myra can do the qubit prep for you. And this is particularly nice when you have many samples to measure. And before I dive into the setups, I just want to mention that these more complicated setups can be downloaded from BMS homepage. And there are lots and lots of other setups there as well to play with if there are other applications you are interested in. So visit that homepage if you are interested in seeing if there is any applications that you could be something for you. So the first setup is the 16S ITS setup for the MAB kit. It involves 3 different steps. So you have the PCR setup and the normalization and the library prep. And in this example, we have 8 16S samples and 8 ITS samples. And in the first step, the assays are mixed on a 96 well plate before the amplification that we do on a Gene Explorer PCR machine. And when the PCR is done, it is time to measure the DNA concentration on a qubit. And this step can also be assisted by Myra, as I mentioned, but not the actual measurement, of course, but the pipetting of all the tubes for it. And I will show you this later. And in the second step here, the samples are normalized. The DNA concentration values are measured by the qubit and are then entered into the workbench interface. Myra then calculates how the samples need to be diluted in order to reach the desired concentrations. And I will also show this in more detail later. And after the samples are ready for the last step, the library prep, where the magnetic station is needed, this is the more complicated protocol. So I will show this in much more detail later. But for now, I can just mention that it involves some incubation steps where the protocol pauses so that the sample plate can be manually transported off deck to the barcoding incubation of the barcoding incubation step and the proteinase K incubation step, which are also done on a Gene Explorer. So the end product after this is a 15 microliter library in a 0.2 milliliter tube that is ready for the final steps before loading on the flow cell. So for these 16 samples, the Myra protocol takes 7 plus 7 plus 33 minutes. But the last step there also has the incubation steps included, and they take 47 minutes. So all in all, the process would take about 1.5 hours. And that is not included the PCR step and the qubit measurements. The next setup is the whole genome sequencing setup, which is based on the rapid barcoding kit. The setup is simpler and it takes a lot less time. However, it does require a lot more DNA. So making sure that the extraction platform is up to task is important, and also making sure that the bacteria are properly ELISed and before the extraction is also key to making this work. These steps might make up for the time gained by not having a PCR step. So all in all, it might take more or less the same time anyway. Just as in the previous 16S ITS setup, here we also have a normalization step. It differs from the previous one in that in the amount of DNA that is needed, and other than that, they are the exact same protocol. The VGS library prep, however, differs somewhat. And in this case, in this example here, I just wanted to show you the upper limit of what can be prepared, which is 96 samples divided over 4 libraries. This will require larger amounts of ethanol to wash, and also a larger waste disposal, which are these over here. And that's why they are bigger than what they were in the previous setup. And this would be an absolute nightmare to do by hand. But with Myra, once the barcoding step is done, you can more or less just leave this running and do something else for the remaining hour or so. If you only have 24 samples, it will take 35 minutes to finish the protocol, and that's because there are some timers in the protocol that are just as long regardless of the number of samples. And the final setup I want to show you before we dive deeper into the details is the one for SARS-CoV-2. And it is possible to add something in-house here as well. And that is also true for the 16S ITF kit, although it all depends on what and for what purpose. So we have run 8-locus MLST with this protocol, and it works well. But if you want to sequence the SPA gene in S. aureus, for example, you need to keep the amplicon intact. So that would require a ligation-based kit, such as the one in the previous setup for 16S ITS. So in this particular example, we have 10 SARS samples and 8 in-house samples. And SARS is an RNA virus, so the first step is to translate it into cDNA. We have 2 gene explorers, one for pre-PCR and one for post-PCR. So the cDNA step is done in the pre-PCR gene explorer. And after this step, we can set up the PCR assays. And the Midnight protocol for SARS-CoV-2 sequencing has 2 different primer mixes. You have A and B, and that is why we have 3 mixes being prepared here, one for A and one for B, and one for the optional in-house mix. And the 4th tube here is for the polymerase. So the PCR step after this is very lengthy, which is why it might be preferable to do these first 2 steps on day 1 and the next 2 steps the following day. And the 3rd step is to pool the A and B amplicons of SARS and to dilute the amplicons before the library prep. One could choose to do a normalization step here as well, but we have noticed that it is rarely needed, not for the SARS samples at least, but the in-house amplicons might need some adjustments. So, in the last step, the library prep, it works in the same way as it does in the protocol for whole genome sequencing. But here I just wanted to show you that it is possible to pick whatever barcodes you want from the barcode plate. And it's easy that you end up with a barcode plate with leftovers that are scattered all over the plate. And it can be a bit of a headache keeping track of which one went to which sample. So yeah, this makes that a lot easier. And you can also go back and look at it again if you become confused later. So now let's take a closer look at what happens in the library prep. And this example is going to be based on the MUB kit version, which has 1 step more than the rapid barcode kit does. So the first thing that happens when the protocol is started is that a message pops up that reminds you to vortex the ampure beads. They can stick to the bottom of the tube, which is a bit difficult for the functions in Myra to get unstuck. So you could do this vortex later as long as you don't forget to do it. And the next step is that EDTA is added, and then the barcodes are added, and then another message pops up that prompts for a off-deck barcoding incubation. And the instrument will pause here and will not continue until you tell it to. So once that is done, the next step is that the heat unstable proteinase K is added, and another off-deck incubation prompt shows up. And this is the incubation step that is not needed in the rapid kit. Otherwise, they are very much similar to each other. When the plate is back, the samples are pooled, and then the ampure beads are added. And as I mentioned before, the ampere beads, they are mixed by the Myra, but it helps that it is vortexed before, so that the bead pellet is loosened enough from the bottom of the tube. And after this, another user method shows up, this time for the Hula mixer. We don't use a Hula mixer here. Instead, we just properly mix with a pipette and set the timer manually for about 10 minutes before continuing. And after that, the magnetic slider is moved in place before transferring the barcode amplicon plus bead mixture to a empty well on the plate, and a timer is started. And after that, the waste liquid is discarded. And after this, wash buffer is added. We have had more success using 80% ethanol, but we can't really explain why that works better. Anyways, whatever you choose to wash the beads with, the wash is done 2 times. And after this, the magnetic slider is moved away, and the elution buffer is added. The pellet is then resuspended, and the timer lets the sample sit for a while. And then the magnetic slider is moved back into play. A timer allows the bead to pellet properly, and 15 microliters of the library is transferred to a 0.2 microliter tube. And this is then ready for the last few steps before loading on the flow cell. So I would like to ask if there are any questions so far related to this.
I can just add in that you can write any questions in the chat or raise your hand, and I can enable you to speak.
Okay. If not, we will continue and talk a little bit about the normalization and how that works. So the instrument does the calculations itself. So here to the right, you can see what amounts of diluent are taken and what amounts of samples are taken to the destination plate. Well, for this particular example. And when setting up the protocol, the values from the qubit are entered into a column next to the sample names. And in the destination view, there are some options to set up on how you want the instrument to behave with too high and too low concentrations. So here you can enter your specific concentration you desire. And there are some boxes to check that will determine what happens with the too high and too low concentrations. So the simplest one for too high concentration is just that a error message is generated. A better option is to have the instrument prompt for additional tubes where a pre-dilution can be done. And you can also choose to have a higher destination volume, but that would not be a good choice in this particular example because there are other things that are added to the samples later. And for too low concentrations, such as if you have a whole genome sequencing sample that is below 21 nanograms per microliter, you can also choose to have an error message generated where you then get the option to choose what you want to do with that particular sample. And you can also choose to have the source ignored by default. And in that case, the sample will be ignored completely. Or you can pick skip source, and the sample will also be ignored, but the destination well it was meant for will be left empty. So that will allow you to add it later after a re-extraction, for example.
I got one question in the chat here.
Yes.
So the question is, where have you placed the Myra, since it works with both pre-PCR setup and amplicons, etc.?
So we actually have two Myras, but the one that we use for this is in the human genetics department, where we don't work with microbiology samples in routine. If that answers the question. So it is for microbiology sample, it is only used for NGS.
Okay, thank you.
And yes, the last choice here is to let the instruments take the sample anyway and leave it undiluted. This could be a good option to check if the two low samples always are borderline low. But this could possibly be wasteful if the samples more often than not are far below the desired concentration. And we are actually nearing the end of the presentation. I just want to show you this one more thing here about the qubit prep. So I personally find it rather laborious and boring to manually pipette the 2 microliters of sample to the 198 microliters of qubit working solution, especially when there are lots of samples to deal with. And if you have large hands and have had too much coffee to drink that day, it can really become a struggle. So this is, of course, also possible to set up on the Myra. And there are to these microcentrifuge blocks, there are these purple inserts that make it possible to fit the qubit tubes. So that is a very nice feature. And I have a little movie here that will show you how Myra deals with the aluminum foil on the barcode plate. It uses a tip to pierce the foil, then changes to another tip before transferring the liquid. So in case someone was thinking about this as a possible source of contamination, this is how that risk is limited. And to sum up our experience using Myra, I would say that we find it easy to set up, easy to run, and easy to learn, which means less risk for mistakes, and that library prepping becomes a standard procedure rather than it's no longer an art. Anyone can do it just as well as the next person. And this saves us time and effort. The workflows are not in themselves necessarily faster than doing everything manually, but considering that other things can be done instead and that less mistakes are done, time will be saved. And I would, however, want to stress how much mental energy is saved by using Myra, and how much faster this is to learn for someone that has little experience or little previous experience with sequencing. So all in all, it's a very versatile and nifty instrument that I wouldn't want to be without. So I want to give a shout out to my brother in arms here, Christopher. He's normally seated right behind me, but not today. We've had a lot of fun together setting up the Myra protocols, and Chris, he gives the Myra 5 out of 5 stars.